All right. Hello and welcome to another edition of Physical Science at Home. In case you couldn't notice, I am also at home here today. So, very excited to talk to you about displacement versus time graphs. The first graph we have is actually a graph of my walk, Mr. Smith's walk. I took a walk today, it was a great time. So, like any walk, I walked a certain distance, or in this case, displacement, and I walked it took a certain amount of time. Now, this is a very much abridged version where you'll notice that it takes a total of 16 seconds, and I travel at most 40 meters away from my house. Now, that's important here because I don't travel a total of 40 meters. In fact, I travel much further than 40 meters. But that's something that we're going to talk about here. So if you look at the graph, it tells you in the first 4 seconds, I travel 25 meters. In the second 4 seconds, by 8 seconds, I travel another 15 meters to get to the total of 40. Then from 8 to 12 seconds, you'll notice that my displacement doesn't change. And then from 12 seconds to 16 seconds, I walk from 40 meters all the way back to 0 meters. So, how much distance did I actually cover here in the walk? The answer is 80 meters. I covered 80 meters of space in these 16 seconds. Now, this is a great example of what a graph will look like on your test here coming up on Friday. Here's a great example on the screen of some of the questions you'll see. It says questions to look out for. These are all going to be phrased as during what time was Mr. Smith? And then here's where the questions are going to come in. So for A here we have moving forward. So at what times or during what length of time was I moving forward? Part B is asking what time was I moving backwards? C says moving the fastest. D says moving the slowest. And E is stopped. What I want you guys to do right now is go ahead, take a moment, and answer these 5 questions. Go ahead and pause the video. I'm going to look at my fish while you do the thing. So hopefully you have some answers. Let's talk about them. Let's start with A, moving forward. Now, any point in time where I'm going positively from 0 towards 40, that would be considered moving forward. So I would say times 0 through 8 would be considered for A. 0 through 8. And then for B, moving backwards, what time was I moving backwards? That would be the time starting at 12 and then going to 16 seconds, 12 to 16 seconds. So far, hopefully that makes sense. Moving forwards versus moving backwards is really an issue of anytime I have a positive slope, I'm moving forward. Anytime I have a negative slope, I'd be moving backwards. Those are kind of the generalizations you can draw. For questions C and D, moving the fastest versus moving the slowest, this is going to be an issue of steepness. So this is going to be not just slope, but absolute value of slope. So we want the slope that's either the greatest number, whether that's positive or negative, for moving fastest, and then the slowest slope would be the number that's closest to 0. So for question C, moving the fastest, I was moving the fastest between 12 and 16 seconds. Even though I was moving backwards, I was still moving the fastest. For moving the slowest, we would say that I was moving the slowest during that time 8 through 12, which is also the answer for E. 8 through 12 is also the answer for E. In both those cases, I was stopped. I was not moving at all, so that would be moving the slowest. So these are the type of questions that you can expect for displacement versus time. I think that covers everything. There might be some other questions. So take a look at your notes and take a look at the other videos where we do talk a little bit about graphs and kind of what they symbolize, what they mean. Let's move on to velocity versus time.